Hello everyone, welcome back to my channel. So in this video we are going to learn about elliptical polarization. Okay, the third type of polarization, that is elliptical polarization and its types. Right, left is elliptical polarization and right elliptical polarization. So all these concepts we are going to learn in this video. Okay. If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. So elliptical polarization. So elliptical polarization is achieved. Elliptical polarization is achieved when X and Y components, when X and Y components of E bar are not equal in magnitude okay, and phase difference between them is odd multiple of pi by 2. Odd multiple of pi by 2. Okay, so if the magnitudes are also not equal and phase difference between them is odd multiple of pi by 2, then it is called as elliptical polarization. So what can we say is linear polarization and circular polarization are special cases. Okay, sorry. So linear and circular polarization are special cases of elliptical polarization. Okay, so both are special cases of elliptical polarization. So in this EOX is not equal to EOY, that is magnitudes are not same, and also phi y minus phi x, that is del phi, is equal to 2n plus 1 into pi by 2, again plus or minus. If it is plus, okay, so if it is plus, it represents right elliptical polarization, and if it is minus, it represents left elliptical polarization. Okay, same concepts as circular polarization, right? So in this case, what will be E bar? If I take right elliptical polarization, that is plus if you take, okay, so E bar is EOX e power minus alpha z cos of omega t minus beta z ax cap plus EOY, because magnitudes are not same, EOY only, e power minus alpha z cos of omega t minus beta z plus pi by 2 ay cap. Okay, so for z is equal to, for simplicity, z is equal to 0, so E naught of 0 comma t is EOX, so this will be 1 cos of omega t minus beta z ax cap plus EOY into cos of pi by 2 plus omega t, so you'll get minus sign, so I'll write directly here, so minus EOY into sine of omega t ay cap. Okay, because since cos of omega t plus pi by 2 or cos of pi by 2 plus omega t is minus sine omega t. Okay, minus sine omega, sorry, this beta z is also vanishing, so no beta z here, cos of omega t only. Okay, so what is x component here? Ex is EOX cos omega t, right? Similarly, Ey component is minus EOY sine omega t. So this is totally EY component, magnitude of EY, and this is totally magnitude of EX. EX is this. So EX by EOX, EX by EOX is cos omega t. Similarly, EY by minus EOY or EY by EOY is minus sine omega t. So if you take EX by EOX whole square plus EY by EOY whole square, so what will be this on the right hand side? Cos square omega t plus sine square omega t. So this will be equal to 1. Okay, so on the right hand side, so taking square on both sides, you will get cos square omega t plus sine square omega t. So its value is 1. So this is of the form x square by a square plus y square by b square is equal to 1, where a and b represents the ellipse, right? So it represents the coordinates of the ellipse. Okay, cutoff points of the ellipse. So this is of the same form, x coordinate here, so x axis here, so x coordinate here ex, and a square, so there is a constant e is 0x here. Similarly, y axis here, ey here. Okay, so this represents the locus of ellipse. So that is why it represents an elliptical polarization. Okay, so this is happening because it is not equal in magnitude and phase difference is odd multiples of pi by 2. So if they are equal in magnitude, then it again becomes circular polarization. Then elliptical polarization becomes circular polarization. That is why we have said that linear and circular polarization are special cases of elliptical polarization. Okay, so that is the reason, right? So next we'll see the classifications, different classifications of elliptical polarization, right? So if the difference of phase, that is phi y minus phi x, is positive odd multiples of pi by 2, then the polarization is called, that type of polarization is called right elliptical polarization, right elliptical polarization, or it is also called clockwise elliptical polarization. Clockwise elliptical polarization. Okay, just as we have seen the same in the case of circular polarization. Okay, so in that case the locus will be like this. Okay, the locus will be like this. It is in the form of ellipse. So this happens when Ex0 is greater than Ey0. Again there will be intercepts on x-axis and y-axis. So this is very less when compared to this. So this is Ex0 and this is Ey0. So this is very near to origin when compared to this. So Ex0 is more when compared to Ey0. So when Ex0 is more when compared to Ey0, so this is the graph, or this is the orientation. So it is in this direction, in clockwise direction only. Okay, so this is the first case in again right elliptical polarization. So if you have the second case will be like this. Okay, so this, right? So this happens when Ey0 is greater than Ex0. Ey0 is greater than Ex0. So this is more when compared to this. So by seeing only you can see. So this is Ex0, intercept on x-axis, that is Ax cap along x direction, and intercept along y-axis, that is Ay cap, so is Ey0. So when Ey0 is more when compared to Ex0, so this will be the locus. Okay, so this is again in the clockwise direction only. Okay, so these are the two types of elliptical polarization, or two types of right elliptical polarization, and it again depends on the intercepts on x and y axis respectively. Okay, similarly, when del phi, which is equal to phi y minus phi x, is negative odd multiple of pi by 2, negative odd multiple of pi by 2, then that type of polarization is called left elliptical polarization, or it is also called anti-clockwise elliptical polarization. Okay, anti-clockwise elliptical polarization. And again you have two cases again, when Ex0 is greater than Ey0. When Ex0 is greater than Ey0, so locus will be of same shape only, but the propagation is, but the moment of this points will be in anti-clockwise direction, like this. Okay, anti-clockwise direction. So that is why it is called as left elliptical polarization. And again, if you have the other type, okay, like this. So this will be a y cap, this is ax, sorry, this is ax cap, and this is a y cap. So when Ey0 is greater than Ex0, so this is the locus, this is the locus. Okay, so it will be again in anti-clockwise direction, like this. Okay, so these are the four types of elliptical polarizations. Okay, depending on again Ex0 and Ey0 values, you have two types again in both right side, right elliptical polarization and left elliptical polarization. Okay.